Good afternoon. Today's math class, we are reviewing the math packet. There was a little confusion because I have the assignment for today is that it's due today, the reviewing of the math packet. So those of us at home, we're just reviewing. We don't have to have the math packet turned in today, just that we are reviewing the packet, and at home you're going through and listening to the video, making sure you know how to do the pages. The packet, as you can see, is due on the 25th, so next week, Friday. So packets are due next week, Friday. Remember, Khan Academy is due tonight. It is a Thursday. It was assigned last week, Wednesday. So I was checking. There's a lot of us that have our 100%, and we're good to go. But there's still quite a few of us that need to work on those Khan Academy assignments. So make sure you're getting your Khan Academy done. It's due tonight. I think that's it for our little upkeeping. So, housekeeping. So let's look at our first page of our math packet. Let's look at how we answer this one. So a dance company held auditions to fill 3 spots in the company. After the first round of auditions, 2/3 of the dancers were cut. After the second round, only 1/4 of the remaining dancers made it to the third round. 2 were cut after the third round, leaving 3 moving on to the fourth round. How many dancers attended the auditions? So with a problem like this, where there's lots of numbers being thrown at you, it's really easy for the numbers to kind of swirl around in your brain and you're not sure how to answer it. This is where making a bar model comes in handy. So bar models aren't taught a lot in math. At my old school, we did Singapore math, and they teach bar models a lot. So I just learned bar models a couple of years ago, and I really like them for word problems like this, and I'm going to show you why. Because it really takes the information that they're giving you and makes it make sense, and you can solve it quickly. There are ways that you can do word problems finding the math equations to do, but sometimes it takes us a while to get there. So if we do a bar model and we put our information onto our bar model, we can do it quickly. So when we're doing a timed test, like when you're in high school and you're taking the ACT or the SAT, you're able to solve the problems a lot faster. So let me show you how we would use the bar model for this problem. So a bar model means we're going to make a bar, and we're going to take the information that we're given in our problem and we're going to put it into the bar. So the dance company held auditions to fill 3 spots in the company. After the first round of auditions, 2/3 of the dancers were cut. So if my whole bar are all of the dancers, so the whole bar is all of the dancers. How do you think I should break up my dancers if I know 2/3 are cut? Chase?
You take out 2/3.
I'm going to break it up into thirds. And I know that 2/3 are cut. Make sense so far?
Yeah.
Okay. So our next line says, after the second round, only 1/4 of the remaining dancers made it to the third round. So these were my remaining dancers in this unit right here. And 1/4 of them move on. So what do I want to do to that unit? Leah? Split it into 4s. Not very even. They should be even, but I wasn't being very even with those. So I know that these first group was cut in the first round. If 1/4 move on, then I know 3 of the 4 are cut in our second round. Now it says 2 were cut after the third round and leaving 3 moving on to the fourth round. How many dancers attended the auditions? Well, if 3/4 were cut and 1/4 was left, and of that 1/4, we had 2 cut and 3 moving on, how many dancers are in that fourth? Ashley?
5.
5. We know there were 2 cut and 3 moving on, which gives us 5. These are all equal units, right? We cut it into fourths. I didn't do a good job making them look equal, but when we cut something into fourths, they're equal parts. So how many were in this section?
5.
5. How many were in this section?
5.
How many were in this section?
5.
So how many are in one large unit?
20.
20. 5, 10, 15, 20. If we know there's 20 in one large unit, how many are in our other large unit?
20.
How many are in our other large unit?
20.
Can we figure out how many dancers there are? We did it awfully quick, didn't we? So when you get one of these kind of confusing word problems and we're not sure exactly how to do it, see if you can put it into a bar model. Break it up with the information that they're giving you. Really think it through. If I'm making equal parts, how does that work? And it will help you to be able to solve your problems quicker. Okay. Any questions on that? There are lots of word problems that I now just automatically go to making my bar model. I don't even stop to think, what are the equations? How can I do it algebraically? I'm getting the same answer, and I'm getting it a whole lot faster. And that's okay, as long as you get the same answer. Andy is going to take a 30-question test in which he earns 9 points for every correct answer. He loses 5 points for every wrong answer and loses 1 point for every question he does not answer. Is it possible for Andy to earn a score of 0 on the test? And if so, how? So I talked about this the other day. You cannot just say that he doesn't answer any questions so he gets a 0, because we lose points if we don't answer a question. We can go into negatives. Whew. Who wants to take a test like that where you can lose points? Oh my goodness, I wouldn't want to get negative answers. But Andy can get negative answers. So you have to really be careful when you're counting it. You're going to want to say, you're going to need to tell me how many correct answers he has, how many wrong answers he has, and how many unanswered. So you can't just say yes or no. You need to tell me how many correct, how many wrong, and how many unanswered. Show me the math. Okay, if he had 10 correct, that would be 90 points, because each correct answer gets you 9. So then how many incorrect times 5? How many wrong times 1? And when we add and subtract all those numbers, you should come up with 30 questions and a 0 for the points balancing out to be 0. I have seen several different ways people have answered this question. There is not just one correct answer. You need to make sure your way works. Okay? So make sure your way works. Do not ask a friend, how'd you do it? What'd you get? And just write it down. That's not going to help you learn. Okay? That's cheating. You can bounce ideas off of people. I'm okay with that. But saying, well, what'd you get? Oh yeah, let me write that down. You're not learning. It's not going to help you. The whole point of doing these math packets is to help you learn how to solve these kind of problems. So when we get to the test like the MAP test, when you get into high school and you get to the ACT or the SAT, you're able to answer your questions. Okay, don't cheat yourself out of learning how to answer these word problems. Word problems are meant to be kind of tricky, to make you think. Okay, so you want to have your brain get exercised. We want to grow your brain. Okay? Don't just hear what other people are putting and put that down yourself. Challenge yourself to learn it and to grow. Five-card challenge. We know 5-card challenges. I have had people ask me, hey, can I just put a 5 down and get a simple, easy point? Why would that not work? Paisley?
Because it says it has to be at least 2 portions.
Yeah. It has to be at least 2 cards. It has to be an equation. Has to have an operation in it. Has to have more than one number. So if we just write a 5, it's not an equation. There's no operation happening. So it will not count. So you actually have to exercise your brain a bit there and do the math. All right, next one. This one, you really can't see it on my scan here, but our shaded area is here and here. So this is the shaded areas. It says find the area of the entire figure and the shaded region. The figure is a square and 2 semicircles. The given measure is the radius of the circles. Round your answer to the nearest hundredth. All work must be shown. So what's the first thing we want to do, Paul?
We find the area of the figure.
We have to find the area of the figure. Our figure is a square. How do you find the area of a square? Katie?
Length times width.
Length times width. Do we know our length or width?
Yeah.
I know my radius is a 6. Naveed?
Since the radius is 6 and it's on the edge.
Commission, excuse this interruption. Will the student council please come to the office? Student council members to the office. Thank you.
All right, go ahead, Naveed.
You need to multiply it by 2.
Yeah, because 6 is halfway to the middle. So we know that there's going to be 6 on this side. So multiplying 6 by 2, 6 plus 6, 6 times 2. So, all right, so we know that length and width of a square are the same. So if we're 6 plus 6 here, that's going to be the same amount here. So we should be able to get the area of our figure pretty easy. Now there is no measurement with the 6. There's just a 6. So when you have a measurement that actually doesn't have a measurement listed, you just call it units. It's 6 units. So our answer would be units squared. Okay, we don't put our number and then put a square after it. So, yes.
So would that be the same thing for the shaded region too?
Yep. Which is why I put it on there.
Oh, I can see that.
Okay, so you don't ever want to figure out an answer. Let's say if we did our length times width, we got 25. We wouldn't put squared right after the 25, because then that would be 25 squared, not units squared. So we want to make sure if there isn't a unit listed that you put it as units squared. Some of us are accidentally putting that square right after our number. We don't want to square the number. We're squaring the
Joey and
measurement.
Isabel Flavor to the office. ASAP. Joey and Isabel, thank you.
Did you have a question, Katie? Okay. All right. So I can find my area of the figure. How do I find the area of the shaded now? What do I have to do? Paul?
So we can combine the 2 semicircles to make a circle and then find the area of the circle.
Why would we want to find the area of the 2 semicircles, Paul?
You want to find the area of the 2 semicircles because it then well, you're gonna those 2 things are taking up the shaded region.
The 2 white spaces, the 2 semicircles, we don't want to include. We want just the shaded area. So if we know how to find the area of a circle, we don't know how to find the area of these goofy shapes. But if we can find the area of that circle that the two semicircles make up, we can subtract that out and we'll be left with our goofy shape. So we need to find the area of the white, which will be units squared. But that means we need to know how to find the area of a circle. What is the area of a circle, Paisley? Pi r squared. We know pi is 3.14. We know our radius, the r, is 6. So do the math and you find the area of the white. And then like Paul said, we want to subtract the area of the white from the full figure. So we're left with our shaded area. Paisley.
Technically, since you still have to. Technically, if you add 2 then half circles together, that equals circles, so you don't have to divide it by 2.
Correct. If you're adding 2 semicircles, you form one large circle. You don't have to divide it by 2. You could do a semicircle, do the area of a circle and divide it by 2. Do the semicircle, do an area of the circle and divide it by 2, and then add those together and subtract it from the. That's a lot more work. It would still get you the same answer. It's easier if we just combine our 2 semicircles to make one circle. Chase.
I just did the thing, and if you subtracted it from the whole squares area, it would be a negative.
No one. So you did something wrong, and we can look at that later. Okay? So come see me later. All right, let's look at our next page. And you're not the first one that accidentally gets a negative. I think the first thing I want to tell you to check is make sure that you start with the area of the figure and you subtract out the white circle. Some people accidentally do the white circle and we subtract out the area of the figure and then we go negative. So that could be what you did. That is what other people have done that have asked me for help on that one. So make sure you start with the area of the figure and then subtract the white out. All right, so our figure page. Now yours is in black and white. You can still see the squares on it. Green is the light, purple is the dark. Okay. For pre-algebra, we need to complete the table. Now, this is one of my favorite of the figure pages that Mr. Schultz gives us because we use lots of my favorite numbers. What are my favorite numbers?
Squares.
Oh, the perfect squares. They are so fun to work with. My challenge to you is to see if you can come up with the rules, not the pattern, but the rules for each of these, for the green, the purple, and the total. So when we get to, if I were to tell you how many green blocks would be in the 75th figure, you'd be able to figure it out like that. Okay, not following the pattern. So the pattern we can find is fairly easy. My challenge, a little bonus challenge, is to see who can challenge themselves to find the rule. You don't have to, but I challenge you to. Mm-hmm. So let's look at how we can find the pattern for our figures. How many green are in my first figure? Somebody just say it. How many are in the second? How many are in the third?
9.
How many are in the fourth?
16.
So I gave you the big hint that these are my favorite numbers. It's going to help you find the pattern. So look for those perfect squares. What numbers are we squaring? Can you follow the pattern? So let's look at the purple. How many purple squares are there in the first figure? How many in the second?
32.
How many are in the third? Really?
No,
Oh, I know.
That's
That's
not 81.
Oh, that's 72.
How many are in the fourth?
128.
Okay. Those ones are not as easy, but once you kind of start thinking it through, you can see how the perfect squares tie into those rules. So the purple does have a perfect square in the rule that you're doing. Now let's look at our total. How many total in the first,
9.
second,
36.
third, and fourth? Those ones are perfect squares straight up. So you can follow the pattern to complete the table. So the green are perfect squares, you can follow a pattern easy. The total are perfect squares, you can follow the pattern easy. The purple, not quite as easy, but if you know the total and you know the green, can you find the purple easy?
Yes.
Yeah. So if you know the total, take away the green and you're left with purple. So you can fill it in easy. But again, I challenge you, and I might have to see if I can have a reward for anybody who meets my challenge, to find the rule for the green, the rule for the purple, and the rule for the total.
Can it only be one person? How much people can get?
Whoever does the challenge. But in order to meet my challenge, you cannot ask any friends for help. You cannot say, what rule did you come up with? Nope, you have to do it yourself. Okay? So you have to be able to do it yourself to come up with that rule. Finn. Okay. So that's my challenge, is to find the rule for each of them. Because once you figure out the pattern with the perfect squares, filling in the table is pretty easy. Grow your brain. Try to do it better. You're not bringing it up to me right now. Why are you jumping out of your chair? Questions we will do after. Let's look at our next page. The figure below is a rectangular prism. Answer the questions for your class and show your work. All classes must draw a net. How do we draw a net? Again, it's been a while since we had to draw a net. How do we draw a net? Nobody knows? Ashley, how do we draw a net?
Unfold the figure.
Yeah, you're unfolding the figure and laying it out flat. So you're going to want to say, I'm going to take the top of my box, and then I've got the side, and then I've got the long side, I've got the bottom, I've got the other long side. So if you folded it up, you would make that box again. So you have to draw your net. So then it says, if our volume is 360 feet, what is the surface area? They are giving us some measurements here. I think I missed that when I went a little too fast when I was making my answer key. They actually give us some measurements. So make sure you're using those measurements and you're finding for the missing measurement. Okay? I think I helped somebody with this and I didn't realize that they gave us measurements. So make sure that the short side is a 5. The long side is a 9. You need to find what this side would be. What's the formula for the volume of a rectangular prism? Chase? Length times width times height is our volume. If we know 3 of those, can we find the third? If our length, let's say the length, we've got our width, we've got our height, and then we've got Our length is our x. Can you do algebra to find, let's not put a v here, because we know our volume too. So if we put in all of the numbers that we know, can we solve for x? How would we solve for x? What was that, Paisley? How do we solve for x?
First I got 405.
Okay. And what did you get?
I got 45.
So we have 360 equals 45x.
And I divided 360 by 4.
Because 45x means 45 times x. To get x by itself, you need to do the opposite. So once you know x, fill in your numbers on your net. Find the area of each rectangle. Add them all up to find your surface area. Leah, do you have your math packet? Go get a piece of paper if you want to take notes. Oh, and our volume page. I have so many friends that like to say, oh, look, pre-algebra only has to do 3. I'm going to turn my packet in 2 weeks early and say done. Oh, friends, we're all about challenging ourselves this packet giant. Challenge yourself to do more. Don't settle for doing the easy ones. Challenge yourself to do some harder ones. If you get 3 easy ones right, you're going to get full credit. Challenge yourself to solve some more. Okay? Grow your brain. Naomi and Maddie, are you guys listening? Are you? Okay. So, in order to do that, we need to know all of our formulas. Some of us are already starting to memorize some of these formulas. Let's see how we do. What is the formula for the volume of a rectangular prism? Length times width times height. What about a cube? Harrison?
Isn't it side cubed?
Side cubed. Now, we could say length times width times height. Why do I prefer to say side cubed? Ethan? Because I need to remember all the sides are the same. If I just do length times width times height, I might forget that each side has to be the same length. It's a cube. They're all squares. So if you put side cube, you remember they all have to be the same. Who knows the formula for the triangular prism? Ethan. Length times width times height divided by what? 2. If we have 2 triangles, put them together, makes that square, makes the rectangle. So we divide it by 2 because it's only half of the rectangular prism. What about for my pyramid? Anybody know the formula for the pyramid? Izzy?
Length times width times height divided by 2.
Length times width times height divided by 3 because we have those triangles in there. Cylinder. Who knows how to find the area of a circle? Paisley?
Pi r squared.
Pi r squared. Now it's a cylinder. So what do I also have to multiply it by? Times height. The cone. Paul. Pi r squared times the height. What are we going to divide it by? It's a cone, just like a pyramid. 3. Now, the slant that you were talking about, I'm trying to remember which shape it was. It wasn't that was finding the surface area of a cone. So this is finding the volume. So we don't have to deal with that goofy slant unless it's the surface area. Okay, so it's like a cylinder, but because we're taking out like a pyramid, we're taking out the more triangular shape of the cone, we divide it by 3. So we have the cylinder divided by 3. Anybody remember the sphere? Andrea,
I don't remember exactly, but I know it has a 4.
it does have a 4 in it. How do we use that 4? Garrison?
Multiply?
Okay, so we've got a 4. We're going to be multiplying. Any other guesses?
Multiply by 5.
Pi, because we know it's
Oh,
a
I guessed
circle. Circles have that pi. So you gotta keep going. We're not done. Paisley? So there is an R. Now it's not squared because we are cubing it because it's that full circle. So we're cubing it.
Is that it?
Nope. We have to divide it by something.
2.
Andrea?
3. Divide by 3.
Divide by 3. So it's 4/3 pi r cubed. Our next page, it's that Fibonacci page. Our last couple of packets, we've been talking about Fibonacci numbers. This time we throw in the golden ratio. So the golden ratio is naturally pleasing to the eye. It's a pattern. In everything from shapes to nature to human faces, the closer an object is to the golden ratio, the more it resonates with beauty. To many, it is the gateway by which God shows himself in creation. Consider a segment that is divided into 2 parts, A and B. So it's not really a pattern. It's a ratio. So if the ratio of the whole segment is A plus B, to the long section A is equal to the ratio of the long section A to the short section B, the segment has been divided with the golden ratio. Below is a model. We can see the A and the B. So A plus B is to A as A is to B. It's a little confusing. Exactly. But with math, sometimes we give you an introduction to something and then we continue to build on it as time goes on and it starts to make sense. Are we going to understand math completely the first time it's introduced to us? No. So this is the first time we're learning about the golden ratio. It's not easy to understand it right away. So it even says, don't feel bad if you're having a difficult time grasping the golden ratio. It is something that has been extensively researched for centuries. And for as much as mathematicians have learned about it, there is still much that remains a mystery. So it's okay if we don't understand the golden ratio right now. We're just having an introduction. We understand the term and that it deals with the Fibonacci numbers. So how does this apply to Fibonacci? The beginning of the Fibonacci sequence is below. And as consecutive elements are divided, larger divided by the smaller, the quotient approaches the golden ratio. So you're going to see for yourself by writing the quotients below. Round each quotient to the nearest 10,000th. So here are our numbers. You take the 2 numbers and you divide the big number by the small number. So we have 1 divided by 1 is 1. Then we have 2 divided by 1 is 2, right? It's this easy. All you have to do, 3 divided by 2, you put it into your calculator, you're writing out the answers. Okay? So you're just doing the division problems that he's given you. So, like I said, this is just the beginning. It's an introduction to that golden ratio. It's okay that it doesn't make much sense. We're just getting the building blocks. We will get there. Okay? So this is the beginning of understanding it is by doing the division problems. All right. Next page. Mean, median, and mode. So you're at the store and you buy 3 oranges for $1.20 each, 2 bananas for 99 cents each, 4 tomatoes for 75 cents each, 3 loaves of bread for $2.50 each. Find the mean, median, and mode of the prices for each item purchased. There are 12 items. So you need to write out in order so we can find that mean, or we can find the median. So you want to put them in order. What's our smallest number price amount that we have? Paul?
0.75.
How many times do I want to write 0.75? 0.75, there are 4 of them, so I'm going to write it out 4 times. Okay, do the same with the rest of your prices. Remember, if it's an even number like 12 and we have 2 numbers in the middle, what do we have to do? Because there can only be one median. Izzy?
Subtract.
Nope. Nope.
That's what I would.
Garrison?
Don't you add them both and divide it by 2?
Yeah, you find the mean of those 2 numbers, Izzy. You add the 2 together and you divide it by 2. Okay? So we've done this before. We've talked about it. We need to remember it. So when you have an even number, to find the median, you have to find the average of those 2 numbers. Add them together, those 2 numbers, and divide by 2. So the median is the middle. What does the mode mean? Maddie?
The most amount of numbers.
The most. Which number do you see the most? And then our mean is our average. How do we find the mean, Paul?
You add up all the numbers and divide by the amount of numbers that we listed.
You add up all the numbers that you write out. You divide by how many numbers you have. So we know there are 12 items. So we're going to add up those 12 prices and divide by 12. Our polyominoes. So we know how to do this page. Remember, you cannot rotate any of them. You must find how they fit into the word hay. Okay, so fit them into the word hay without rotating any of them. Whoops. Next page. This is important for us all to see. In our directions, it says be accurate, be neat, and use correct labeling. I want to see titles on my graphs. I want to see the labels on the graph. So, no. We have a big empty space here. You have an empty space on the back of your page. If you want to do it on a separate piece of paper, staple it on. What do you think would be a good title for our graph? Looking at our table. What's a good title for the graph? Paisley?
Injuries.
Injuries. Titles go on top. And then we know graphs go like that. What do you think would be a good title for my bottom? Ethan? Injury type. Right here from our table. Injury type. So if we have injury type on the bottom, what am I going to put on the left side? Owen? Frequency. Again, right from our table. So, what do I want to put on the bottom for injury type? What labels do I want to put?
You want to put the injuries that are listed. Like
The injuries that are listed up here. So we're going to have fall,
cut,
burn,
back injury,
back injury,
injury,
Other trauma.
and then oh, sorry.
And then injury not specified.
He's looking down, so I thought it.
What do we want to put on the left side? Sam?
Like the numbers.
Numbers. What number do I want to start with?
1, I guess.
So if we're right at the bottom,
I guess 2 minus 1.
because we're right at the bottom.
Oh, 0.
So if we started with a 2 right here, we wouldn't have any graph for our one that's at 2, right? There wouldn't be anything there. So if we start with 0, because the bottom is 0, we can start right there. We don't have to cut it off. And then because our biggest number is 14, we're not gonna skip count it all. We'll just count up by ones because it's not that much. So I've got all my labels and my titles. What kind of graph? I guess we should have talked about this first. Paul, what kind of graph should I make? I guess we should have decided our graph before we started writing our labels. What do you think our graph should be, Izzy?
A bar graph?
Yeah, bar graph is the easiest way to do it. So the way we have it set up is easy to draw the bars on top of it. So make sure that you have labels and titles and everything is how it should look. So I see a lot of us have already been working on it. Make sure you have all of those labels and titles. So with that, it is the end of reviewing our packet. So we will say goodbye to our friends at home. Do not forget that the packet is due next week. Do not forget that Khan Academy is due tonight. Have a wonderful day.